Yes. Hi all. Now we are in module 3. As you all know that we have already seen what is the first topic of this module, that is we have seen this part, that is what is syntax analysis, role of parser, error recovery strategy. Now we are going to see what is top down parsing. Okay, in this topic, in this entire video lectures, that I'm going to teach you what is top down parsing is about. Okay, so in top down parsing, we cannot directly find or directly conclude from a single topic, rather than it has many inbuilt topics. Okay, so we'll see one by one. So now firstly we are going to see what is grammar first. As I told you before, this syntax analysis will always work with the context free grammars. Okay, so in order to know about context free grammars, we'll just understand the grammar. We'll learn about grammars first, then we'll see one by one. Fine. So the grammar in a compiler design, grammar is a set of rules that describes a structure of programming language. We have already seen this grammar and all in during our TOC class itself. But once again, we'll just refresh what is grammar and why we need grammar for doing the syntax analysis in syntax analysis. Okay, in compiler design, grammar is a set of rules that describes the structure of programming language. It tells how valid sentence are formed. Okay, what combines the symbols, what combination of symbols are allowed, and how expressions are structured. Basically, grammar defines a syntax of a language. For example, if this is your statement, okay, then this the grammar of this, that is the syntax of this particular statement, will be checked by using the syntax analysis phase only. Okay, why grammar is important in compiler? Because during system syntax analysis, that is parsing, the compiler checks whether the source code follows grammatical rule or not. If the program violates the grammar, then that is called a syntax error. So if some rules are violated, then that will be ending up in getting error. Okay, so if by as a end user, we only know the we'll get only whether the error, whether the program is compiled or not. But actually, behind the syntax analyzer helps you to understand whether this process is working proper, whether this thing is done properly or not. Okay, next is a grammar is defined as VTPS. V is your non-terminals, T is your terminal, P is productions, and S is a set of set or a single start symbol. Okay, so V is a non-terminal, so we can say A. Okay, always it will be non-terminals will be represented only in capital letters. Okay, then capital letters, then yes, A will be your non-terminals, and T is your set of terminals. You can have a small letters followed by some brackets, plus, minus, these and all. Also these kind of symbols also called as non-terminals. Okay, then okay, then sorry, called as terminals. Okay, sorry, terminals are small letters. Okay, fine, sorry. Fine. So P is your set of production rules. Okay, so this is how your production will be there. It will be a combination of production will always be a combination of terminals plus non-terminals, right? Non-terminals. Okay, so fine. Next, S is your start symbol. Okay, S is your start symbol. So if, for example, if here S is your start symbol, or not always S will be your start symbol. Just S represents the start symbol. Not always yes, the letter S will denote a start symbol. Sometimes Z might be, so any other non-terminal will be your start symbol. Okay, so this is the example of your grammar, where the terminals are, so first non-terminals. Okay, non-terminals are E and T and F. Okay, I hope you can get the set of capital letters are called as non-terminals, and terminals are small letters where plus, star, open bracket, close bracket, id are called as non-terminals. Okay, the small letters or some set of symbols or terminals. Okay, then this is your production, and finally your start symbol is E. Okay, so this is how you will define your grammar. Okay, so from this we can derive a string. For example, from E I can say E plus T Okay, I can take anything. So E has two productions, production number 1 and production number 2. Okay, from this I can derive two things, right? So instead of this E, I can again write it as sorry, I can use this production because E also gives T. So T plus T. So instead of T, I can use this T star T, right? T star F, okay, and plus T. And instead of this T, I'm using a F, F star F plus. Instead of this T, I'm using another F, and instead of F, I'm using ID. Okay, I didn't complete this production because there should be one. Okay, fine. I don't want to proceed further, so I'm just using instead of okay, ID, instead of this F I have replaced with ID, instead of this F I have replaced with ID, and another F will be replaced with ID. So at the end I got the string as ID star ID plus ID. So if I use this format, I'll have this kind of string. If I use some other format, I'll generate some other string. So through grammar, your strings can be generated. Okay, so this grammar is nothing but defines how your program should be in compiler design. Okay, so the grammar is actually has VTPS, V set of not terminals, and T is terminal, P is production, and S defines your start symbol. Okay, so now important concept related to grammar. So what we are going to learn from grammar in compiler design is, first you learn about derivation trees, nothing but the left derivation and right derivation tree, ambiguous grammar, whether, okay, so we learn about ambiguous grammar, then we learn what is left recursion, left factoring, then we learn what is first, follow, parsing, and LL1 grammar. So why I need to learn these many steps? Because if you, our main aim of learning grammar is to learn about top down and bottom of parsing, right? We are learning about parsing here. Okay, so in order to do this parsing technique, we need to learn these many things. Okay, then only we can, if these 6 steps are followed, these are like steps, if these six steps are understood and learned, then we can do this LL1 grammar. Okay, which is very important for your exam point of view. Okay, so we'll see one by one. Okay, so first we'll start with derivation tree. Okay, so this is just a basic introduction of what is derivation tree is. Okay, it's a simple it's a tree representation that shows how string is generated from grammar starting from start symbol. So how you can generate a tree like structure, it's nothing, it's just whatever I did in the I have generated from the grammar, I have generated a string, right? The same way you can use tree method in order to generate that, that's all. Okay, so that tree is called as derivation tree. It's visually represent the application of production rules, how it is applied and how the tree are generated. In simple words, it shows how sentences form step by step using grammar rules. Okay, so how the string is generated. Okay, the parse tree contain following properties. The root is node is always a node indicating the start symbol. The derivation tree, so the top node, this root node will be your start symbol. Okay, the derivation is read from left to right. So if your production has a production rule has some productions, okay, some grammar has 3 productions, then it will be read from left to right, not right to left. Okay, leaf node is always your terminal node. We all know about what is terminal. It is small letters or some symbols are called as terminal. So leaf node will always be your terminals. Internal node always be your non-terminal. What is internal node means? The inside nodes will be your non-terminals. Okay, likewise, so the leaf nodes will be your terminals. Okay, ID. Likewise, you can have it's open close bracket and one more ID. So likewise, you can have like this is your, it's a tree like structure. Derivation tree is a tree where your start node will be, root node will be your start production, start symbol of your production. Internal nodes will be your intermediate nodes will be your the non-terminals, and leaf nodes will be your terminals. Okay, then your terminals, your productions will be read when you're generating your tree. Your terminals, your production will be read from left to right. Fine, so here is your example. Okay, so here the same okay, the same kind of example I have taken. So there are 3 productions: E gives E plus E, E gives E star E, E gives A R B R C. Okay, so now the terminals are A comma B comma C, and non-terminals are E only E. Okay, so A comma B comma C plus and star are your terminals. Okay, fine. So now if I want to generate this kind of input, okay, a star b plus c, what I can do? So first I have taken e is your root node. Okay, so e is, it starts from e, and left side, so e I'm taking this production. Okay, so e plus e is your production. So e plus e forms a intermediate leaf. Okay, intermediate node. Okay, now from this I want to generate these kind of. So if I need star, okay, a star b, okay, I need star in between. So what I'll do, I'll include e, another this e. So instead of this e, I'll use e star e. So I'll have this node, this kind of tree structure. Okay, so now I got this star. So what I need now, I need a. So from that left node ie, I generated a. Okay, so now I got a and star. Okay, so a is your a leaf node, e is star is your another leaf node, it's a terminal symbol. So I got a star. Then I need b plus c. So how I can generate? So this e is converted, that is this e is converted into b. Okay, so how? From this direction, so e can be small a, small b, small c, right? So I have generated this b. So now I have generated these two things, these three things, a star b. So I got a, one star, and b. I need only plus and c. So here already the plus is there, which is generated from the first time I generated this, right? So I have plus 2. So now I need only c. So from the production number 3, I generated c. So this is what your tree derivation tree is about. So how you can generate, by writing you can generate this in output, right? The same way by using this tree, you can also generate the output. Fine. So this is what your derivation tree is. Okay, now next is, there are two different types of derivation tree, that is left derivation tree, another is right derivation tree. Okay, so the left derivation tree means if you are generating the, from this example. Okay, so I'll just tell you. Fine. So if this is your production, so if this is your tree, if you, this is the given production. Okay, so if this is your given production, and if you want to generate this string, okay, if I'm using the left variable or left non-terminal every time, and I'm generating my tree, then it is called as left derivation tree. Okay, so here this example is left derivation tree. Okay, so leftmost, sometimes it is also called as leftmost derivation tree. Okay, leftmost, because you are always choosing the left out of this. Just see here, there are two non-terminals, e capital E, capital E. From this I'm choosing the leftmost to derive a tree. Here also I have chosen leftmost to derive a tree. Okay, this leftmost is done. So once this generating, once it reaching the terminal point, then I'm using next leftmost. Out of these two terminal non-terminals, I'm using the leftmost one. Okay, so this is called as left term derivation tree. If the derivation tree is generated by consistently applying production rules to the leftmost variable in each step of derivation. Okay, right derivation tree is, a right derivation tree is obtained by applying production rules to the rightmost variable in each step, then it is called as rightmost derivation tree. Okay, so this is an example. So here the given example has this two productions, which has one start symbol is yes, and so variable okay, variables and terminals, right? Variables are yes and a, and non the terminals are a, epsilon, okay, only two, and b. Okay, on non-terminals. Okay, so you can have these three in leaf node, and these two as intermediate or root node. Okay, so that is what it meant. Okay, it mean, okay, so we are starting from the start state, yes. So from that I can choose any one thing, but I have to generate this tree. I want to generate this string by using left derivation tree only. So I need a b b a. So I have chosen this particular, so this second one, this second production, a yes yes. So out of these two non-terminals, I'm choosing the leftmost, okay, to derive a string. Okay, so next I have chosen ass, small a. So I'm using this first production. Okay, so this first value from the production. Okay, now I have generated this. From this I can, I'm choosing the next leftmost. So I have this from ass, I have generated capital A yes, and this yes is there. Okay, this is red. Okay, this is also completed. So out of these three non-terminals, I'm choosing the leftmost to derive the string. Okay, so likewise, if you are choosing the leftmost the non-terminal to derive a tree, then it is called as left derivation tree. Similarly, if you're using the rightmost to derive a tree. Okay, the same string is generated by using rightmost string. So out of ASS, okay, out of these two, I'm choosing the rightmost one to derive my string. Okay, so this is what your left derivation tree, and the types of trees are leftmost left derivation tree and right derivation tree. Okay, next is ambiguous grammar. Ambiguous grammar is one string. If one string can have more than one derivation tree, okay, is called as ambiguous. We all know the term ambiguity mean, right? If it has duplicates, or if it okay, in compiler term, when there are more than one string, the string can be, if the given string can be generated more than once, okay, is called as more than one derivation tree, is called as ambiguous grammar. Okay, grammar is ambiguous if one string can have more than one tree. For example, a star a plus a, I can generate this string in two different trees, then it is called as ambiguous grammar. Okay, if the sentence can be interpreted in two different ways using same grammar, then grammar is ambiguous. So you have a same set of production, same string, but the string can be generated by two different types of trees or many different types of trees, then that is called as ambiguous grammar. Okay, the contextual grammar is ambiguous if there exists at least one string has more than one leftmost derivation or more than one rightmost derivation or more than one parse tree, then it is called as ambiguous grammar. For example, this is your this is the production that we got, okay, that we have, and the string I have to produce is this one. It's a typical classical example, classic example. We always have this example. So here I can generate this thing by using leftmost derivation, as this is leftmost derivation and this is rightmost derivation. So I can generate this string with two parse tree, then it is called as ambiguous grammar. Okay, so why I want to remove ambiguous, I know what is ambiguous grammar, but what I say is I don't want ambiguous grammar in my production, because to ensure, so why I don't need ambiguity in my grammar, because if I have duplication in my grammar, my compiler will not work properly, right? So if I have duplication, so I'm going to represent each and every program language or programming line in tree way, right? Such like a tree. Okay, if I have more than one tree for a particular line, my compiler or my error analyzing my error part will be very bad, right? So if I generate, for example, int a is equal to b, okay, you all know, if I'm giving this particular a is equal to 6, okay, so if I'm giving this particular line into my compiler, first the lexical analyzer will convert it into token and lexemes, right? So it will generate as keyword or keyword id. Okay, a is also called as identifier, so it will become as id, and equal to will be your assignment operator. Okay, then 6 will be your constant, right? So likewise it will give you as tokens and lexemes, and this will be sent into syntax analyzer, where this will be converted into, or will be checked, the error will be checked by using parse tree, where this is my rule how it should be. If I can generate the same thing in two different trees, then my correct error will not be analyzed or checked properly, right? If I have two duplicates of a same sentence, then the error will be very, it cannot be analyzed or error. So because of that only, my I don't want ambiguity in my grammar. Okay, to ensure unique interpretation, to obtain single parse tree, to enable deterministic parsing, okay, like LL1 parsing and LR parsing require non-ambiguous grammar. Okay, so these kind of, so in order to avoid this because LL1 parser, the parser that we are going to use in our grammar checking or the error checking, those needs only non-ambiguous grammars only. Okay, so because of that only, we need to generate, we need to remove the errors. Okay, so we know what is derivation tree, what is the type, what are the types of derivation tree, then we know what is ambiguous grammar, and I'm saying I don't want any ambiguous grammar in my grammar. Okay, ambiguous grammar in my grammar, fine. Next is left recursion. So this is very important topic. What is left recursion? Okay, so grammar is said to have left recursion if non-terminals appears on the left side of your production. For example, see here this example. Okay, so if I have this kind, see, this is your start symbol or any kind of the production, the start of your production, and here you have one more a here, right? So this is called as left recursion. Left recursion happens when your grammar is grammar is ambiguous grammar. Okay, I told you before that we don't want ambiguous grammar, right? In order to remove ambiguous, we have to learn about this left recursion and your left factoring method. Okay, fine. So we know what is ambiguous, what is grammar, what is tree, what are the types of tree. Now we also learnt about ambiguous grammar, which I don't want in my compiler. So what I'll do, I'll try to remove ambiguous grammar. I cannot stop having the ambiguous grammar, but I can remove the ambiguity in my grammar, right? By using left recursion and left factoring, you can remove your grammar. Fine. So left recursion is very mandatory and very important. So listen carefully. Okay. Grammar is said to have a left recursion if non-terminal appears on the leftmost side of your production. What is non-terminal? The capital letters. So here you can see a non-terminal. Yes, the same non-terminal. So A is your production, start of your production, and you have one more non-terminal, right? The same non-terminal in the left side. So this is right side, this is left side of your production. Then that is called as left recursion. Okay, for example, A gives A alpha B. So alpha can be anything, this R can be anything, this R beta can be anything, but you have this non-terminal in the left hand side as well as right hand side, then it is called as left recursion. Okay, so if A tends to A alpha slash beta, then do the following: remove left recursion. Okay, so what I have to do, I have to remove left recursion by following this step. Okay, what is the step? A gives beta A dash is equal to A. So okay, I'll solve this by using this formula. Okay, fine. 1 minute. Fine. So I'll solve. So this is the rule to remove the ambiguity or left recursion. Okay. So this is my question and this is my answer. I'll say how this answer is derived. Okay. The first question is A gives A slash B. Okay. So this is my question. So I told you if I have the the start of my production is same as my first letter of my first string in my production, then it is called as left recursion. Okay, so how to remove? So if your left recursion, if your grammar is in this form, that is A gives A alpha and beta. So what is A here? A is A. What is alpha? Alpha is my small a. What is beta? Beta is my small b. Right. So if I have grammar in this form, what I have to do, I have to do this following. That's all. Just substitute whatever there. So what is there? A gives. Okay. What is A? A is my A. Okay. What is beta here? Beta is small b. Small b. A dash. So what is A? A dash. Okay. So A is my A. I'm just making it as A dash. Now I have to define A dash. What is A dash? A dash is equal to alpha. What is alpha? Small a. What is A dash? The same thing, A dash and slash epsilon. So this will remove my ambiguity. We are not doing anything. We are just removing. I don't want my left side, left hand value should not appear in the first position of my right hand side. That's all. So in order to remove it, that is called left recursion. So left is recurring again in the right side. That is what left recursion. So I want to remove it. What I'm doing, I'm introducing a new symbol called A dash and I'm defining as a production. Okay. So how I'm doing, just remember this formula. Okay, if your production is in this form, then find what is A, what is alpha, what is beta, and rearrange itself as this form. Okay, okay. So it's the first question. Now so now I got this. So A gives B dash, A dash gives A, capital A dash slash E epsilon. Okay, I'll solve this question. Okay, I'm going very slowly. Please learn by yourself. Okay, you can pause the video and learn how it is deriving and you can check with the step I'm doing. Okay, so S gives S0, S1, S and 0, 1. Okay, so what I am going to do, so is this, I know this is left recursion, this is in the format of this. Okay, so what I'm going to do, so A gives A alpha and beta. So why it is left recursion? Because left hand side I have yes, it is recurring in my right hand side as first symbol. Yes. Okay, so this is my left recursion. So this is in this format. So what is my capital A? Capital A is yes here. Okay, so this compare with the formula. Okay, next, what is alpha? The rest letters are your alpha. Alpha is equal to 0, yes, 1, yes. Okay, what is beta? beta is your next part is equal to 0, 1. So we got A, alpha and beta. Now what you have to do, you just have to rewrite in this form. So what is A here? Yes gives. What is beta? 0, 1. What is A dash? I can make it as yes dash. Okay, so A S na, A dash will be your yes dash. Got it? Now I want to, since I have created new symbol yes, I want to generate yes dash here. What is yes dash? How I want to generate yes dash? Alpha A dash. Okay, so what is alpha? 0 yes, 1 yes. What is A dash? Is my yes dash. Okay, slash epsilon. That's all. So now I have removed my left recursion. Okay, so this is how I got this answer. Okay, so fine. Next is my third question. So I'll solve third question. Fine. So now I'll solve the third question. So left recursion is very, very important because that will be helping us to building our parser. Okay, p plus q slash q. Okay, so let me solve it. Okay, so how I got, so this is in the format of A gives A alpha slash beta. So what is my A here? It is p. Okay, what is A dash? Then it will be p dash. Okay, so alpha will be, if p is my A, then rest things will be my alpha plus q. And what is my beta? Beta is very just q. Okay, so now I have to define as A gives beta A dash and A dash gives alpha A dash slash epsilon. So I have to make this in this format. So how we can do? A is my p, so I'll just put p. What is beta? Beta is my q. Okay, what is A dash? A dash is my p dash. Okay, now A dash is my p dash gives, what is alpha? Alpha is plus q. Okay, what is A dash? A dash is my p dash and epsilon. So this will be my grammar now. Okay, so fine. So okay, I have written it wrongly. So this is p and this is p dash. This is p dash. This is p dash. Fine. So fine, while uploading, I'll change and upload. Okay, so how I hope you got it. So what is left recursion? If your left side character appears again in the first position of the right side, it can also be like this also. So sometimes you'll have p gives q slash p plus q. You can also have this. So this, what does it mean? P q and p gives p plus q, right? So this is also a production, right? So if so, this two steps are rewritten as in the single line. That's all. So if you got this also, so left side is reappearing the right side of first point of your right leg. This is also left recursion. Okay, so whenever you got this kind of format, then you can blindly change into this format. Okay, so this is what your left recursion is. Okay, so I hope you get what is left recursion is. Next is left factoring. Left factoring is another type where your grammar is appearing for number of times. Common prefixes are protection. What is prefix? The first part of your or a particular letter is keep on reappearing again and again. Then it is called as left factoring or non-deterministic CFG. I'll show with an example so that it will be very useful. Okay, I don't want to confuse you with the what is it with the formula. It is very simple when you just start doing it. Fine. So first question. Okay, so I'll solve this question. So first is yes gives I. Okay, so here left factoring na, if you have common prefix, take it together, make it as a single production. That is what left recursion, left factoring is. Yes gives I. Okay, I'll solve. Okay, let me solve one by one. I E, first thing, T S slash I E T S E S and A, and E gives B. Okay, so here this is your production. Okay, so now I can, let me see, just check whether the first, see the first production. Okay, here IETS is repeated twice, right? So here it is also repeated and this is repeated here also. Okay, so I'm taking it as common. For example, I'm taking for example, if I like mathematics, what we'll do, I E T S, I'll take it as common. So if I take that from here, it will become empty. Okay, so this is or, right? So I can make it as plus, just in order to understand, make you understand, I'm putting it as plus. Okay, plus IETES is taken out. Now what will be left? ES will be left. Okay, then this A I'm just writing as such. Okay, like mathematical term I'm making it. Okay, so I'm making this as my new production S dash. Okay, so how the first production becomes? S gives I E T S. I have taken it from here, followed by, I'm not going to repeat this, rather than I will make it as S dash slash A. Okay, so now I made it like this. Okay, now I want to define S dash. Okay, S dash, what is S dash here? It is ES, sorry, it is nothing but ES. I just put plus because it is like this only, it's going to be, it is this and plus is same. Okay, so ES or epsilon slash. Okay, so that's all. Okay, so it is ES or epsilon. Okay, then you have one more production called E gives B. Okay, no more common terms, I'm stopping it here. Okay, so this is my production, right? I can define any variable here. I have used A here. You can use your own variables. Okay, so you're taking everything common, and the common thing is your first production. The things that are not common will be taken, are made as new production. That's all. Okay, so let me solve your second example. I have 4 examples, so I'll solve one by one so that you'll understand clearly. Okay, the next example is, okay, this one. Okay, from this you can see what are the common things. You have A as common. Here it is B, second term is B, A. So I cannot take that out, so I'm taking small a common. So if I take small a common, what will be there? AB slash or plus, I can put BC or AC, I'll take it as common. So I'm making this as a new production A dash. Okay, so A will be, now I'm rewriting my production, A into A dash. Okay, so instead of this commoner, I'm putting it as, I'm replacing with A dash. So A will be A dash. A dash is, now I want to define my A dash. What is my A dash? AB or BC or AC. Okay, now when I see, I have two common A terms, so I can make it as common. Common, if I take A outside, I'll have B slash C, and this BC will come here, right? Okay, are you getting? So here A, B and AC is here. I'm taking A as common, so that I have B, this slash, this C will be taken out, and this BC will be at the end, right? So I'm redefining my A dash. So this I'm making it as A double dash. So A dash, okay, please learn slowly. Okay, so A dash will be A, I've taken this BC, I'm taking it as A double dash slash BC. Okay, so this A double dash I have to define. What is A double dash here? That is B or C. Okay, so this is, sorry, not plus, it is R. Okay, so this is how you can define it. Okay, let me show another example. Okay, learn slowly so that you'll understand clearly. Okay, yes gives, okay, see here B is common. Next yes is common, right? So I'm taking BS outside. Okay, so just, yes, I'm taking BS outside. So yes gives BS, B and small capital F, if I take it out. Yes, capital S, AAS from this term, and SA, SB, okay, or SA, SB is common here, and only small b is common. Okay, and one more production. This I'm not taking it as common. Okay, so I'm putting it separately. Okay, remember max. Okay, so what this will be my S dash. Okay, so if what will be my S production? BS followed by S dash. Instead of this bigger term, I'm making it as S dash slash B. Now I defined my S. Now I want to define my S dash. What is S dash now? S dash is this one, yes small a yes, or yes a yes b or b, right? So this is my, this only my yes dash. I'm not taking this b and this bs. Okay, now check for the commoner. Yes a is commoner, right? So yes a I'm taking it out, so what will be the left? Yes a s plus yes b, and this B is taken. Okay. So now this is my yes double dash. So what will be my yes dash becomes? So this is my defined yes dash. Now I have taken the common out. So again I'm redefining my yes dash. So this is my yes. Okay. What will be my yes dash? Yes dash is yes A. Okay. This is written as yes double dash slash P. Okay. So I got this. I got this. Now I want to define my yes double dash. So what is my yes double dash? It is AS or SB. Got it right? So this is how you will solve your left recursion, left factoring. Okay, so do it slowly, you'll understand. Okay, yes gives last question AB, ABC and ABCD. Okay, what is common? You all know A is common. So so if I take A outside, it will be empty. B, BC, BCD is taken out. Okay. So what now I'm defining my yes again. Okay. Because from yes only I have taken a common. So this is my yes dash. So yes will be A yes dash. Okay. Now I'm taking finding defining S dash. What is S dash? Epsilon or B or BC or BCD. So among this B is commoner. So I'm taking epsilon without epsilon I'm taking B outside. So this becomes epsilon. Okay. This if I take B outside, C will be there and CD will be here. Okay. So now this is my yes double dash. So I'm redefining. So this is my yes. This is okay. Now I'm redefining my yes dash. So epsilon will be there. So instead of okay epsilon, or I have taken B outside B. What is this term called? Yes double dash. Okay. So I got here B. Okay. Here I have defined as A. Okay. A S dash. A B double dash. Okay. Now I want to. So this is my yes double S dash. Okay. Now I want to define yes double dash. What is yes double dash here? Okay. Best double dash is C or CD or epsilon. Take common C. So epsilon or D. Okay. So now I'm redefining my yes double dash. So yes double dash will be C. Instead of this, I'm making this yes triple dash. C S triple dash slash epsilon. Okay. So yes triple dash will be D or E. So do it slowly, epsilon. So do it slowly, you will get how I'm doing it. Okay, just replace with the characters you have. Okay, so now we have completed 4 topics. Okay, one is what is derivation tree. Then we saw what are the 2 types of derivation tree. Then we saw what is ambiguous grammar. So if you are doing parsing, then you should not have ambiguous grammar in some parser. So in order to remove ambiguous grammar, we have to have left recursion. We have to learn left recursion and left factoring. Left recursion is nothing but if your left hand side product is appearing again in the first letter, first place of your right hand side, then you have to remove it. If your left hand side, for example, A gives A S slash B. Okay, if this is your production, and if it is appearing here, it is your left recursion. A gives S A B. Here it is not appearing immediate after left recursion, left side, right? So this is not your left recursion. And similarly, if it is in this form, okay, so this is a left recursion. Okay, so see the differences. If your first letter, every time your first letter after the arrow mark, your first letter should be your the same production, same letter as your left hand side, then that causes left recursion. Okay, next we saw left factoring, where your if the letters are repeated in your production, you can take it as common and you can make it as a new production. Why we are learning left factoring and left recursion? Because we need to avoid ambiguity. So in order to avoid ambiguity, we need to do this. In order to remove ambiguity in our grammar, we need to learn this left recursion and left factoring. I hope you understood. Rest of the things will be taught in next classes. Thank you all.